So, introduction of the cloud computing. So, in this lecture, I'm going to discuss mainly about the architecture part. So, what do you exactly mean about the cloud computing architecture? It means that it refers to a design and structure of the cloud computing systems which enable on demand access to a shared pool of resources such as it might be servers, storage, and application over the internet. So, there are some of the key components of the cloud computing architecture, that is the front end, back end, network, hypervisor, and the virtual machines. And there are some of the cloud service models, as I discussed in the previous lecture, that is the IaaS, PaaS, and SaaS. So, there are also some of the deployment models where we are going to discuss about that also here. So, those are that like public cloud, private cloud, hybrid, and the community cloud. So, now we shall discuss this one by one. So, cloud computing is a utility oriented and internet centric way of delivering IT services on demand. These services cover the entire computing stack, whether it might be from the hardware infrastructure, which is packaged as a set of virtual machine, to the software services such as development platforms and distributed applications. Now, let us go into the cloud reference model. So, cloud computing supports any IT services that can be consumed as a utility and delivered through a network, like most likely the internet. So, such characterization include quite different aspects, that is infrastructure, development platforms, applications, and services. So, when we look into the architecture part of it, it is possible to organize all the concrete realization of the computing into a layered view, covering the entire stack that is mentioned in this figure. And it is from the hardware applications to the software systems. The combination of cloud hosting platforms and resources is generally classified as a infrastructure as a service. We can organize the different example of IaaS into two categories. That is, first one is the management layer, and second one is the physical infrastructure. Okay, some of them provide both of it, and others they might only provide the management layer. Okay, now let us look into the picture. So, this is the diagram that illustrates the layered architecture of the cloud computing and its service model, including IaaS, PaaS, and SaaS. So, now let us look into one by one. So, here, as you can see, there are the cloud resources at the bottom of the stack. This is the foundation layer consisting of physical resources such as servers, storage system, and some networking components. These physical resources form the backbone of the cloud computing services. And some of the virtualization technology abstract these resources, enabling efficient allocation and dynamic provisioning. Next, here comes the core middleware, that is the virtualization layer. This handles the virtualization and management of cloud resources. So, there are virtual machines that provide the isolation and scalability for multiple tenants. So, next, there is the VM management and deployment. It is a tool that facilitates resource allocation and monitoring. This layer abstracts the physical infrastructure, making resource available on demand. So, next comes the cloud hosting platforms. So, this layer focus mainly on QoS negotiation, that is the it ensures service quality, including performance and uptime guarantees. Next is SLA management. So it maintains service level agreements for quality commitments. And next is monitoring and metering. So it tracks resources usage for accounting and billing purpose. So next comes the cloud programming environment and tools. This layer provides tools and environments for developer to create and deploy application. Examples such as Web 2.0 technology, which I have detailedly discussed in the last lecture. and mashups, distributed programming frameworks, workflow, and libraries. Developers leverage these tools to build cloud native applications that effectively use distributed resources. Next comes the cloud application, that is the user application layer. So, this top layer consists of the end user application and services that operate on the cloud. So, these include social computing, enterprise software, scientific computing, and the CDN means the content distribution networks. This is the layer which interacts with the user by consuming the underlying cloud services seamlessly. So, as you can see here, there are cloud service models, that is the IaaS, that offers the fundamental computing resource, that is, it might be VM, storage, and networks. Next comes the platform as a service that provides an environment for application development and deployment without managing the underlying infrastructure. Next, it comes the software as a service. So it delivers complete software solution over the cloud. So in this right hand side of the diagram, you can see adaptive management and autonomic cloud economy. This the diagram emphasizes the importance of adaptive management, which ensures that cloud service scale and adjust dynamically based on the demand. So this is all about this figure. So next, this is some of the explanation. So yeah, might be this is understandable since I explained all this in this diagram itself. So this is a table which signifies the cloud computing service classification. So, there are three categories, that is software as a system service, platform as a service, and the infrastructure or hardware as a service. So, in SaaS, the customers are provided with applications that are accessible anytime and from anywhere. So, some of the product types are web application and services, and for this, the vendors and the products are Salesforce and project management tools. So, in the platform as a service, customers are provided with a platform for developing the application hosted in the cloud. So, it might be programming APIs and frameworks, deployment systems. So, some of the examples here are Google App Engine, Microsoft Azure, Anika, and Data Synapse. So, next comes the infrastructure or the hardware as a service. Customers are provided with the virtualized hardware and storage on top of which they can build their infrastructure. Virtual machine management infrastructure, storage management, network management, and some of the examples here are Amazon EC2 and S3, GoGrid, and etc. So, if you consider infrastructure and hardware as a service, then they are the solution that are most popular and developed market segment of the cloud computing. They deliver the customizable infrastructure on demand, and the available option within the IaaS offering umbrella range from single servers to the entire infrastructures that may include the network device, load balancers, and the database web servers. So the main technology used to deliver and implement these solution is hardware virtualization. This is one or more virtualized machines opportunely configured and interconnected. It defines the distributed system on top of which applications are installed and deployed. So, it is possible to distinguish three principal layers, that is the physical infrastructure, the software management, and the user interface. So, this is the diagram for the infrastructure as a service reference implementation. So, this diagram represents a comprehensive view of cloud infrastructure management, showcasing the integration of physical infrastructure, virtualization management, and user interface. So, first it comes the physical infrastructure layer. This is the foundation layer that is consist of hardware resources such as data centers, cluster, and the desktop or heterogeneous resources. So, what do you exactly mean by data center? So, large facilities housing physical servers and storage devices, it compose the data center. Next, a group of interconnected servers that work together to improve the computing efficiency is what the cluster are. And desktop or heterogeneous resources are the physical system and devices of various types connected to the cloud infrastructure. These resources form the essential backbone of the cloud computing services. Next comes the infrastructure management software. This layer is responsible for dynamic allocation, provisioning, and management of cloud resources. So, first comes the pricing and billing. It tracks resources usage and manages payment systems for services consumed by the clients. So, next comes the quality of service SLA management. SLA means service level agreements. So, it ensures service quality and adheres to service level agreements with the clients. Next comes the monitoring. So, it continuously observes the system health and its performance and the usage metrics to maintain the system stability. So, next comes the reservation. It allocates specific resources in advance for the scheduled task or the workloads. And then the VM image repository, it stores the virtual machine templates and configuration for rapid deployment. Next, the VM pool management. They handle group of virtual machines, providing resources, scaling, and efficient management. Next comes the scheduling. It manages the job execution and resource allocation based on the predefined priorities and the condition. So now after we see this one, so next it is interconnected with the provisioning layer. So it automates the allocation of the resources and deployment of services, ensuring that client receives the necessary infrastructure dynamically. Next comes the web-based management interface. So, this is an interface that provides access for administrators and clients to interact with the cloud infrastructure through web services. So, basically, web services means the APIs that allow automated interactions between the different software components. So, next comes the portals, user friendly dashboards for managing services and resources. Next comes the REST API. They are the lightweight, scalable interfaces for programmatic management and control of cloud resources. So, these and all are integrated with the third party IaaS solutions. So, the system supports resource scaling and redundancy by integrating with external cloud providers, enables the hybrid cloud configuration. It allows the seamless use of additional infrastructure from the third party providers when internal resources are found to be insufficient. So, this is what the explanation part for this figure. So, some of them I have mentioned it here, just go through. And next, it comes the platform as a service. So, in the platform as a service, let us understand it by this diagram. So, this diagram illustrates the architecture and components of a platform as a service in the cloud computing, highlighting its relationship with the IaaS providers, middleware, and user interface. Okay, so first it comes the physical infrastructure layer. This is foundation that So, in this physical infrastructure layer, we have the data centers and desktop and heterogeneous resources, as you can see here. So, data centers houses the physical servers and network equipment, diverse types of physical computing systems for processing tasks. Next comes the IaaS providers. Okay, this layer abstracts and virtualizes the physical infrastructure. They provide virtual machine storage and networking resources on demand. Next comes the PaaS core middleware. So, this is the heart of the PaaS architecture responsible for enabling the development, deployment, and management of application. So, here we have elasticity and scaling. It automatically adjusts resources based on the workload demands to ensure the performance optimization. Next comes the resource management, allocates and manages the virtualized computing storage and networking resources. Next comes the runtime environment. It supports the execution of applications in a scalable, isolated, and managed environment. Next comes the application management. It provides tools for deploying, monitoring, and updating applications. So, next comes the user management. It handles authentication, authorization, and account management for developers and also the users. Next is the web based interface where we are having the web services and portals and also the REST API, which I have discussed in this diagram. So, same holds good for this also. But here you are having another separate thing, that is the programming API or the libraries. They provides access to frameworks, APIs and libraries that developers can use to build the cloud native applications. So this is the explanation of this diagram. So in this we are having the three major classification, that is the PaaS 1, 2 and then 3. So PaaS 1, they are the runtime environment with web hosted application development platform, rapid application prototyping. So there are some of the product tab, just go through it. And then the PaaS2, they provide the runtime environment for scaling web application. The runtime could be enhanced by additional components that provide the scaling capabilities. So in the PaaS3, the middleware and the programming model for developing distributed applications in the cloud come into effect. Okay. So the first category identifies PaaS implementations that completely follow the cloud computing style for application development and the deployment. They offer an integrated development environment hosted within the web browser where applications are designed, developed, composed, and deployed. This, for example, if you want to take force.com and long jump is the best suitable example for this first category. So, in the second category, we can list all those solutions that are focused on providing a scalable infrastructure for web application, mostly the websites. In this case, developers generally use providers API, which are built on top of the industrial runtimes to develop applications. So for this, the Google App Engine, which is the one of the most popular product in this category, they provide the scalable runtime based on Java and Python programming language. So next comes the third category, which consists all those solutions that provide a cloud programming platform of any kind of application, not only the web application. So among this, the popular is the Microsoft Windows Azure, which provides a comprehensive framework for building service-oriented applications. So they there are some of the essential characteristics, that is the runtime and framework, abstraction, automation, and the cloud services. So which I think I have explained while explaining you about this diagram. So next comes the software as a service. So yes, next comes the software as a service part. So software as a service is a software delivery model that provides the access to the applications through the internet as a web-based service. So the SAS model is appealing for the application serving the wide range of users and that can be adapted to the specific needs with little further customization. So this requirement characterizes the SaaS as one to many software delivery model, whereby an application is shared across multiple users. So this is in case of the CRM and ERP application. So what do you exactly mean about the CRM? So it is the acronym for the customer relationship management, and it identifies concern related to the interaction with the customer and prospect sales. CRM solutions are software systems that simplify the process of managing customers and identifying the sales strategy. So, ERP is also an acronym for the Enterprise Resource Planning. It generally refers to an integrated computer based system used to manage internal and external resources. This includes tangible assets, material and financial and human resources. So, next comes the types of the clouds. So, in the previous lecture, if you remember, we had discussed only public, private, and the hybrid. So, here we are going to discuss about the public, private, hybrid, as well as the community clouds. So, in the public clouds, they are open to the wider public. So, public cloud constitute the cloud computing in which the services offered are made available to anyone using it from anywhere. It might be any location and at any time through the internet, whether it might be the morning, night, or evening, anything. So, at any time throughout the internet. From a structural point of view, they are a distributed system most likely composed of one or more data centers that are connected together, on top of which specific services are offered and are implemented. So, any customer can easily sign in with the cloud provider, enter their credential and billing details, and use the services offered. So, some of the fundamental characteristics are multi tenancy. The cloud is meant to serve a multitude of users, not only a single customer. So it offers some of the different kind of services. They are the infrastructure, platform, or the application. So we have the famous provider, that is the Amazon EC2, that provides the infrastructure as a service. And then the Google App Engine, it is a public cloud that provides an application development platform as a service. And next comes the Salesforce.com, which provides the software as a service. So, next comes the private cloud. So, they are only implemented within the private premises of an institution. So, and are managed accessed only. That is the members of the institution or a subset of them only can use this. So, private clouds are virtual distributed systems that rely on a private infrastructure, and they provide internal users with dynamic provisioning of the resources. Instead of pay as you go model, as which we saw in the public cloud, so here there could be some better schemes in place taking into account the usage of the cloud and proportionally billing the different departments or section of an enterprise. So they have many advantages that might be like keeping the core business operation in-house by relying the existing IT infrastructure and reducing the burden for maintenance. And some of the key advantages are customer information protection, infrastructure ensuring service level agreements and compliance with standard procedures and operation. So, this figure provides a comprehensive view for the solution together with some reference to the most popular software that we use day to day activity. So, at the bottom of the layer of the software stack, we have the virtual machine technology. It might be Zen, KVM, and virtual machineware. So, they serve as the foundation of the cloud. Virtual machine management, they provide the technologies such as VMware, vCloud, Eucalyptus, and OpenNebula. Those can be used to control the virtual infrastructure and provide the solution for them. So, Then, among the options available for the private deployment of the cloud, we can consider Data Synapse, Zimori Pools, Elastra, and Aneka. Data Synapse is a global provider of the application virtualization software by relying on the VMware virtualization technology. So, Elastra Cloud Server is a platform for easily configuring and deploying the distributed application infrastructure on the clouds. So next comes the hybrid or heterogeneous clouds. The cloud is a combination of the two previous solutions, that is the private and the public clouds. So these are most likely identified as a private cloud that has been augmented with resources or services hosted in the public cloud. So the public clouds are having the large software and hardware infrastructures that have the capability that is huge enough to serve the needs of the multiple user, but they suffer from the security threats and administrative pitfalls. So for this, private clouds are the perfect solution where it provides the security and it maintains the all the things which cannot be provided by the public cloud in terms of the security. Okay. um yeah, so this is the diagram for the heterogeneous cloud where they result from a private cloud that integrates with the additional services or resources from one or more public clouds. So, as you can see here, the hybrid cloud is composed of the private cloud as well as the public cloud. So, a hybrid cloud is a computing environment that combines the elements of both private and the public cloud, enabling organization to take the advantage of the benefits of the both models. So, this approach allows business to optimize their infrastructure, balance the security, scalability, and the cost efficiency. So, some of the key components, if we want to see here, that is the private cloud. It consists of dedicated resources managed by the particular organization for enhanced security and control. It includes IaaS and PaaS as its core components, which provide the virtualized resources and development platform for internal use. Examples include on-premise data centers, cluster, and desktop grids. Next, we can see here is the public cloud. So the public cloud is managed by the third party providers and it offers a scalable on demand computing resources. So it enables organization to handle the peak workloads by provisioning the additional resources dynamically. Common providers include AWS, GCP, that is the Google Cloud Platform. So next we have the dynamic provisioning in between of private and the public. It is a crucial feature of the hybrid clouds where resources are allocated based on the demand. This ensures efficient use of the computing power, reducing unnecessary cost while maintaining performance. Organization can automatically shift workloads between the public and the private cloud environments. So, if we see the benefits of it, then it is the cost efficiency. So, how it is cost efficiency means the organization save money by keeping sensitive workloads on a private cloud and they will use the public cloud for temporary or peak demands. So, the second benefit is the scalability, that is, the public cloud resource can be added or removed based on the demand. So the next benefit is the security and compliance, and the last benefit is the business continuity. This is what the diagram explains about the hybrid or heterogeneous cloud. Next comes the community cloud. So this is the community cloud. So a community cloud is a shared cloud computing model designed to support a specific community of the users who have the common interest, policies, security requirements, or compliance needs. Unlike public or private cloud, community cloud provides a collaborative environment where multiple organizations share infrastructure and services. These organizations may belong to the same industry, government agency, or enterprises. So, some of the key component if we see here, so there is the infrastructure block here. So the underlying infrastructure is shared among the participating organization, and it can be managed internally by one of the community members or externally by a third party provider. Next comes the development platforms. So the community cloud provides platform for application development, enabling organization to build and deploy software solutions. These platforms are tailored to meet industry specific requirements such as healthcare, finance, or the government services. So next comes the application services. Cloud community users can access shared application services such as database analytics or enterprise software. So, next comes the public and private cloud integration. So, community cloud may integrate elements of both public and the private cloud, ensuring a balance between cost efficiency and security. So now comes the question is who uses a community cloud? So it might be government or a public sector, that is different government bodies collaborate to share resources while ensuring compliance with regulation. If we want to take an example, a national government cloud that serves various ministries and public service departments. So next comes the industries and enterprise. So if I want to take an example, then hospitals sharing patient data securely under health regulation. So in the private and third party cloud providers, a research community cloud that allows scientists from different institutions to collaborate on high performance computing tasks. So now let us go into the benefits of the community cloud. Their cost efficiency, since resources are shared, operational costs are lower than the private clouds. Security and compliance, collaboration and resource sharing, scalability and the flexibility. So this is some of the examples. So there are media industry, healthcare industry, energy and other core industries, public sector, scientific research. So these are some of the other benefits. So the main drivers of the cloud computing are economy of scale and simplicity of software delivery and its operation. In fact, the biggest benefit of this phenomenon is financial, that is, pay as you go model offered by the cloud providers. So, in particular, cloud computing allows reducing the capital cost, eliminating the depreciation or lifetime cost, replacing software licensing with subscriptions, cutting the maintenance and administrative cost of the IT resources. So, next is the in case of the small startup, it is possible to completely leverage the cloud for many aspects. It might be IT infrastructure, software development, CRM, and the ERP. So, in terms of pricing models introduced by the cloud computing, we can distinguish three different strategies that are adopted by the provider. That is the tiered pricing, per unit pricing, and the subscription based pricing. These are the three types of pricing. So let us know one by one. So in the tiered pricing, in this model, cloud service are offered in several tiers, that is, each of which offers a fixed computing specification and SLA at a specific price per unit time. Per unit pricing means this is the model which is suitable in most of the cases where the principal source of revenue for the cloud provider is determined in terms of units of specific services. It might be data transfer, memory allocation. Subscription based pricing means this is most usually by the SaaS providers in which the users have to pay a periodic subscription fee for the use of the software. So some of the open challenges are, so basically in this section we are going to highlight some of the most important one, that is the cloud definition. It characterizes the cloud computing as on demand, self service, broad network access, resource pooling, rapid elasticity, and measured services. They are classified into three major services: SaaS, PaaS, IaaS, and categorizes deployment models such as public, private, community, and the hybrid clouds. So, next comes the cloud interoperability and standards. Cloud computing is a service based model for developing IT infrastructures and applications like utilities such as power, water, and electricity. To fully realize this goal, introducing standards and allowing interoperability between solutions offered by different vendors and objectives of fundamental importance. So, next comes the scalability and the fault tolerance. The ability to scale on demand constitutes one of the most attractive features of the cloud computing, where clouds will allow scaling beyond the limits of the existing in house IT resources, whether they are the infrastructure or the application services. Next is the security, trust, and privacy. They are the major obstacles for massive adoption of cloud computing. The massive use of virtualization technology exposes the existing system to new threats, which previously were not considered applicable. So, in the organizational aspects, cloud computing introduced a significant change in the way IT services are consumed and managed. More precisely, storage, compute power, network, infrastructure, and applications are delivered as metered services. So, in this lecture, I have almost covered all the basics of the architecture. So, just revise it once again. If you have not seen my first lecture, do see it so that you will understand this more clearly. So, I think I have covered almost everything. So, thank you guys for watching the video. If you found this as the useful, please do like, share, and subscribe. And if you have any doubts, please do feel free to message me in the comment section. Bye bye.